So as we're here in Module 3, we're going to be looking at a unit, and it's going to be called Top-Down Assembly Method. Up until this point in SolidWorks, you have assembled things from what we call a bottom-up approach, meaning we have to draw all the individual parts or model all the individual parts and then bring them individually into our assembly and model the assembly. This is a different approach where we start actually at the assembly level. We draw in the assembly, and we maybe even use some of the existing parts to create other parts. So we're creating everything in the assembly mode, and then, if you would, kind of exporting it to then, finish up the drawing in the model. More efficient way, especially when it's something brand new and you don't really have an idea of, how things are going to go and you're in the design process. It's easier to design in this way. So there are two tutorials that I'm going to have you go through, and we're going to talk about these two assignments. So I'm going to go into the learning plan first. And as you can see here, I'm really just doing an overview. So I'm not going to be demonstrating these. These are really good tutorials. I've gone through them. Okay. So I know what's there. And I trust that at the level that you guys are at, that you're going to, feel comfortable kind of going through that. And, since we're in our second year, if you would, along the path of our program, I do want to start kind of, pushing a little bit towards back at you so that when you're out in industry, you get used to kind of, figuring it out yourself a little bit. Now, again, it's not that I'm not going to help you. I don't want you to think that, but I'm not necessarily going to demonstrate each and everything. The other thing that I'm not going to do for this unit, starting this unit, is there's no drawing guides. Okay. The last unit you guys had, or the last module, you had drawing guides to work off of as a foundation. Now you're going to start and you're going to make your own drawings. Okay. So I know you're ready for that. Okay. So there's going to be two tutorials. The first one is the mini vise. Okay. Now I have mine printed out underneath my camera, but the full PDF is right there for you. So you're going to make this little mini vise. Okay. The two parts that you're going to make at the top down level are going to be the base, which is right here. And then I think it's called the sliding jaw. And then you're going to create the rest of the parts, and then you're going to pull those into the assembly. They're really easy. They're throughout this tutorial. So it's a really good process, but you're actually going to be creating these two parts in the assembly. That means that you're, doing the sketching, doing the extruding, all that kind of stuff. And you can see how that looks when you're at that assembly level. Okay. The other one that you're going to do is going to be the water control valve that we see here. So either side of that water control valve, those are two parts that sandwich together. You are going to be creating those in that top-down form, and then you're going to be downloading the additional parts to add into the assembly. Okay, so then you're going to kind of finish up, if you would, bottom up. Okay, so you're not committed to one or the other when you're in assembly mode. So you could do a bottom-up assembly, have all of your parts in place, and then just design one or two parts, in the assembly, and then in a top-down mode, for maybe to kind of figure out, what your space constraints might be, or use existing geometry so that you can make the parts match up, effectively. So there's really a lot of advantages to this process. So two tutorials for you to go through. Now, a couple things about the tutorials. Okay. The first one, the mini vise, you're creating all of the parts. Okay. So you're creating two of those main parts, as I said, in the top-down method. And then I think there's 4 that you have to create at the end of the tutorial. Very simple parts. Okay. In the control valve, 2 of them you're going to be creating in that assembly mode, top down, but then you're going to download the rest of these items. Okay. And then you're going to be pulling those in. So these are existing SolidWorks models that you're going to put into the same directory wherever you have your assembly. Now, couple things. You're going to be creating the detail and assembly drawings for these. Again, notice there are no drawing guides. Okay. Now we'll look at each of the assignments, but you're going to be using the WCTC borders that I have for you out there. Okay. You are the designer. So you're going to dimension and tolerance for fit and function based on what's looking here. So I'm not giving you anything. Okay. Make sure to consider tolerances in the title block, okay? Don't forget about those. So you don't have to put a tolerance on everything or a fit on everything, but know that every every dimension has a tolerance and it'll default to whatever the title block tolerance is, and make sure it's appropriate for whatever you're using. Where there are parts that are going to mate with one another, and there are some, there's not a ton, but there's some, I want you to use the fit tables, okay? And when I talk about the fit tables, these are from the last module that we looked at. Okay, they're these guys. Okay, whether it's a RC fit or an FN fit, that's going to be up to you to establish and put on the drawings. You're going to apply GD&T on each drawing. Every drawing is going to have the GD&T. If you have a feature of size, for instance, a hole, you need to position it. Okay, you need to position it. So position tolerance has to go on there. You also need to qualify any surfaces that are datums with like a flatness or perpendicularity, parallelism and such, and then any others that are appropriate. But every drawing will have GD&T on it. So the next time we get together, I'm going to spend some time on GD&T, just kind of refreshing us, doing that surface mode and feature of size mode chart. And I think that's going to, hopefully kind of bring back all those good memories of the class and the rules. Okay. So that's kind of in a nutshell what we have. Now, specifics for each one of these, let's go to each one of the assignments. So if I go back a level here, I go down to module 3. If I look at assignment 3A, this is the mini vice. Okay. I would suggest that's your first one that you work on. Here is the PDF to download or view as you're going through. Now, you're going to create detailed drawings for the following parts, okay? Now, you're going to save each one of these parts as a file name. So remember, our WCTC borders will populate the part number with whatever you call your file, okay? So I want you to continue to use that process because that's going to be what you do out in industry, okay? So I want your file name to be at least 5 digits, okay? So I don't want any files named 1 or 2 or 3, okay? I want them to be 5 digits long, okay? Typically what you do is you call your assembly, let's say 3600 or 36,000, and then you call then the parts in there 36,001, 36,002, because it's kind of like a family of parts that go in that assembly. Does that make sense? That's what I would suggest to start with, okay? But you can make the part numbering system whatever it is. No letters, no names. I don't want anybody's name as part of your part number, okay? It's going to be numbers, part numbers, okay? Now, you're going to make one for the lead screw, the crank handle, the crank knob, and then the base and the sliding jaw are the 2 that are inside of the assembly. So these 3 parts, very simple. At the end of that tutorial, it gives you all the details for those, okay? Each one of these drawings you're going to notice is worth 20 points. I am not pulling out, you're not going to send me a picture of the models. I don't want to see them anymore. I don't need to. You guys know how to model at this point. All I want are final PDFs of the 6 drawings. Okay, so you've got 2, 4, 5 details, and then you're going to have 1 assembly. The assembly is worth 10 points. Each one of these is worth 20. Okay. Now, each one of these drawings that are worth 20 points, you get 2 points for doing the WCTC border. Okay, I have a couple of people pulling in borders that aren't WCTC borders, so WCTC borders. You also have to fill out that title block appropriately. I have people putting text in lowercase in title blocks. Nails on the chalkboard, okay? Every piece of text has to be in uppercase on any drawing. That's an ANSI standard. Yes, SolidWorks will let you do it, but that doesn't mean it's right. You are the person, okay? You are the human with the brain, okay? So make sure you fill that out appropriately. You are the designer, dimension and tolerance for fit and function. Make sure to consider those tolerances in the title block. Apply all the dimensions using the ANSI standards. That's 8 points. So any locations, any sizes, if you're not pointing to things appropriately, if you know how SolidWorks, if you have a threaded hole, it'll put that note and it's in lowercase too. So don't use it. It'll be like 1/4 tapped hole. That is not to the ANSI standard. You have to delete that. And then you have to reestablish that dimension, okay? Do not put hole callouts or threads in with a leader, Don't do it. You can dimension it. You can put a smart dimension and click on that hole and it's going to call it out for you. And then and then that ensures that when that leader is pointing to that feature, if you would extend it, it goes down through the center line. Do you remember what I mean by that from tech drafting? Okay. If you don't, let me know if you have problems with that. Use the fit tables on anything that mates. So not every drawing is going to have this. So I just put 2 points, on there for that when appropriate. And then apply GD&T. That's going to be worth just as much as your regular dimensioning, if you would. 8 points. So anything that's a feature of size has to have a position tolerance. As we talked about in GD&T, there's no reason not to use it. Okay, so I'm insisting that you use it now. If you leave GD&T off of every one of your prints, you can, but you're losing 8 points. Okay, losing 8 points. So be aware of that. Qualify all your surfaces with flatness, parallelism, perpendicularity, whatever it might be, okay? And then any other tolerances that seem like they would be appropriate. So I want you to search out opportunities for GD&T, okay? All right, and if you have questions, that's my job. That's what I'm here for. Then you're going to create an assembly drawing for that mini vise assembly. Only 10 points because honestly, this is ballooning, a couple of views, and a couple of parts. I mean, totally, I think it's 5 parts. That's it. So it's not really involved, but make sure you fill out the title block completely, use appropriate size border, good spacing for views, and isometric. I am going to be judging your drawings on how does it look. when I open it up, it shouldn't be super crowded. Okay. If you don't have room for dimensions, well, then you got to pull a different border in or put it to a different scale. Okay. So make sure that it looks good. Something you would hand to somebody so that they could, on the shop floor, make it. And those drawings, believe it or not, they're reflections of the work that you do, of the knowledge you have, of the skills that you've obtained, okay, while you've been going through here. So you want to make sure that it's to the standard, it's workable, and it looks okay to hand to somebody, okay? So that's part of your grade. So make sure that you kind of look at all these elements and take those things into consideration. There are only 6 PDFs that you are going to upload. So through I think it's the plot or the print function, you can then do the PDF through there like we've been doing for drawings. Okay. So I only want to see drawings. Again, I don't want to see any models. I don't care anymore. If you don't want to rename, I do care. I care that you do good work, but I don't need to see that. You guys have been showing that to me already. If you want, and I would totally suggest renaming the items in the design tree, but if you like, boss and base and cut and whatever, and you like navigating a model like that, that's fine. If you don't want to take the time to do that, I'm not judging you on that anymore. I'm looking at the final product, the drawings that you would then submit and release for production. I see that there's a message here. I might have missed this part number for assembly. Yes, assemblies as well. Any one of these drawings, they all need part numbers, not names. Okay. Again, trying to mimic as much as possible what you would be seeing out in industry. Okay. All right. So questions on this one. This is 110 points. So like I said, you're going to go through the process of the top down, create the initial parts first, create the parts at the very end of our tutorial, bring it together as an assembly and create all the detailed drawings. Okay. All right. The next assignment that you have, if I go back a level, is going to be assignment 2B. Okay. Assignment 2B. Assignment 2B is the water control valve, as we kind of briefly looked at. Here, you're going to do the very same thing, except you don't have to create the models at the end. Okay. You're going to download, I think there was 6. Let me see here at the end. Sorry. So let me point to these because I want to be sure you see this. So for this one, there is some hardware. Oopsie. There is some hardware here. Okay. So what they did, you're going to download the handle. They have a file for the cap screws. Go ahead and download theirs. I'm not worried about them coming out of the toolbox. So just use theirs because that's part of the downloads that you have. There's this lock lever, the thermostat flange, and then the ball valve sub assembly. So this is also a separate part. And then you've got the bolts over here. You do not need to make detailed drawings for the hardware. So none for the cap screws and none for the hex bolts. Okay. You don't have to make any drawings for that. Okay. Usually out in industry, you don't. If it's a standard part like that you just bring in, you pull that in from toolboxes like in SolidWorks. But since they have them here, I just put them as part of the download. You can use them, but you do not have to make any drawings for those. So when we go back over here, the parts that you're going to make drawings for are the handle, lock lever, the thermostat, the outlet housing, and the inlet housing. These two last ones are the ones that you're going to be creating in that top-down method and designing them in the assembly. The other ones are going to be the downloads, okay? All right, so the only drawings you need are what I call like custom parts, like this is a custom part, this one, and that one. So those 4 plus the 2 that you make in the top-down method. Okay. All right. Parts aren't super complicated, but just like on the first assembly, you have to put them on drawing borders, make sure it's filled out appropriately, and do all those same things, including GD&T on everything. So search out places that you can use GD&T because that's going to be 8 points on a single drawing. Okay. All right. You're also going to do an assembly. And again, fill out the title block appropriately and such. Now, remember, we're doing part numbers for each of these. So do not save them as handle. Do not save them as outlet housing. Okay. In the tutorial, it's going to tell you, save this as the outlet housing, save this as the inlet housing. You're going to save it as a part number. Okay. So that it's in your assembly as a part number. And then that way, when you go to open that drawing as its own, it's already on the part number. If you end up calling it that and you forgot, okay, you can change it. It's really not that actually big of a deal, but it's just always kind of nice on the, on the front end if you do, and you don't have to worry about it later on. So knowing that you have an assembly and these parts that you need to come up with part numbers for, plan ahead for that. Okay. Because that way, you know what things are going to be called and what the numbers will be. Okay. So, and I'm not dictating your 5-digit, or at least 5. If you want to use 8, I don't care. Okay. But again, no letters, no single digits, at least 5. And then it's, appropriate. Okay. Oh, it's okay. Please don't. Please don't, Tyler. The question was, could I use 0001? You're just not going to see that on industry. And the reason I'm going to, you might say, well, what's the difference? You're right. You could say you're right. But when you're out in industry, typically, and this was the environment I worked in at multiple companies, you're typically going to have a project. Okay. So somebody orders something from you, and maybe it's a piece of automation equipment. And what'll happen is, what'll happen is somebody's going to assign that project, like let's say 8,500, okay, or 85,000 is going to be the main number. And then all of the individual parts in that assembly or in that project are going to start with 85. And then they're going to have a prefix on it. That way you can be like, oh, the 85 numbers going through the shop right now are for this company, or the 1,200 numbers are for this company. That's very common to do. That doesn't mean that you can't use the parts anywhere else, but you're typically not going to have any projects starting with 0000. You know what I mean? So I'm glad you asked that, but again, trying to just kind of mimic what you're going to end up seeing out in industry. And you probably notice that's kind of the process I took, or the number of system I took with stuff that we've been looking at. Okay. So again, doesn't have to be exactly like that, but if you have your own way of doing it, just don't go too far away from the requirements there. Okay. And so really, again, here, there's going to be 6 PDFs that you hand in for me. You're going to be doing a PDF for each one of the individual drawings here, 20 points each, and then an assembly drawing, for me for that as well. Okay. And I don't want to see anything else but those 6 PDFs. It's like you're releasing this to production and you're telling me, it's ready to go. Okay. And that's the eyes I want you to put on your drawings. Look at every one of the features. Can this be made? Is it to the ANSI standard? Does it look good? Does it look good? Okay. So So those are the eyes that I'm going to be looking at it with. There are a lot of different ways that you can dimension. So I'm not going to be judgmental about that as long as it's manufacturable, as long as it makes sense, and as long as you're applying ANSI standards and GD&T appropriately. Okay. All right. And you guys know all the rules. You've been practicing. So I'm going to let my little birdies fly. Okay. All right. So questions, that's what you have to do for the next 2 weeks. Okay. This is due next week, Friday. For those who are on, task with the assignments that we've been giving, you probably will find this to go relatively quickly, quite honestly. But for those who maybe need some time to finish some things up, this offers a little bit of a breather at this point in the term for you as well, because I know many of you have more than just one class that you're taking as well. Okay, so hopefully it helps in that sense. My goal is gonna try to get module 4 out a little early. So as we look at our calendar, for instance, I'm going to target probably next week, Thursday, to maybe introduce module 4 so that for those who might be ready for it, you would have, you could start working on that as well. 4 is not going to be due till the last day of class, which we're going to have a full 2 weeks to work on that as well. And I believe that is October 10th. So module 4 won't be due until out here. So we'll still have plenty of time to work on it. Okay. And that'll be our sheet metal can crusher dealio. Okay. So questions at all? All right. Thursday, we're going to do some review on GD&T. Okay. So, so kind of be prepared for that. If you have it, might want to dig out your little pocket guide. Okay. It's a good resource. I'll be referencing that as well. Okay. So yeah, so that's what I've got. So if there aren't any questions, what I'll do is I'll stop our recording here